Hello and welcome to another ARM software developer breakdown. My name is Robert Wolf, and in this video, Valentine Viano, product manager from Canonical, will continue building out his Innovation Lab demo. If you missed any of the previous parts to this series, please cruise on down to the description and find the part that you were on. All right, Valentine, welcome back, and I'm very excited for this one. In our last video, you did a step-by-step install of micro Kubernetes on your LXD cluster. Now in this video, I'm told you're going to take it a step further with some containers and VMs and stress testing a use case. So why don't you tell us what you have in store for us this time?
Yes, exactly. So with the microclouds at the edge, one very important feature is that they are high available, that they are redundant. So what we're going to see today is what happens if we unplug one of the nodes. And what we expect to see is that the cluster stay high available, stay redundant, and keeps working. So we are going to observe a cluster of Redis pods that I have already deployed onto the Kubernetes cluster, onto the micro-K8s cluster. And we are going to see what happens if we unplug one of the Raspberry Pis from the cluster. As a reminder, here's our configuration. So we do have 4 Raspberry Pis that you can see there on the microcloud small video, clustered together as 4 LXD nodes. If we look at what's running on these nodes on the LXD layer, we have 4 Linux containers that are running inside of them micro-K8s instances. And these micro-K8s instances are clustered together. So we do have 4 nodes when we do the kube control get nodes. What do we have running on this Kubernetes cluster? So I set up a Redis cluster with 6 nodes, 3 master, 3 slaves nodes. They are working together, they are replicating together. And what we can do is we can extend this information to see where they are located. So you see that some of them are on the worker 2, some on the worker 3, and some on the worker 4. Let's see what's their role in the cluster. So for example, the worker 4 has a copy of the LXD database, so that's a good example. And that's the one we're going to unplug to see what happens in a worst case scenario. So before we do that, I've prepared some scripts to show you some before and after information. So let's do first what's the cluster role. So each pod has a role in the cluster. So you can see, as I said, that 3 of them are master nodes and 3 of them are slave nodes in the Redis cluster. We are going to see how this is going to change. At the moment, the first 3 are masters and the third last ones are slaves. And we can also see the information that the cluster state is in an OK state and that there is no failure at the moment. I'm going to unplug one of the Raspberry Pis. I'm going to watch some status there so we can see what's happening. And first thing, and the first thing is going to be that one of the node is going to go offline, and we're going to see how this goes. So let's unplug the number 4. You see that I've just unplugged it from the Ethernet switch. It's power over Ethernet, so the Raspberry Pi is actually completely down, and that's it. As the Raspberry Pi was the leader in the LXD cluster, you see that it's in a failed state, kind of failed state at the moment, because there is no more leader. So what's happening behind the scenes is that all the LXD nodes together are electing a new leader and are replicating the database to a third node so that they keep a high available configuration, even though we've removed one of the important nodes. So let's just wait for this election to happen. We can still see that even though this is happening in the background, we can still list the containers and interact with them. So that's not blocking at all. That's just a reconfiguration happening in the background. So while this is happening, you can see that one of the containers, the number 4 that was running on the Raspberry Pi number 4, is actually in an error state. We're going to see what we can do later to resolve the situation. So we're going to move it to another node. But at the moment, let's just have a look at what's happening within the Kubernetes cluster. So if we do a get nodes, you can see that it's actually not yet unready. So what we are observing now is that all these layers, they have grace periods, they have timeouts. So it's not immediate, right? You have to wait for the nodes to be observed as not ready. And then you're gonna have to wait for the deployment to kill its pods because it's not ready anymore. So we can also have a look at that. We can do two windows here. Okay, so I'm gonna watch the nodes. Okay, I was too slow. It's already not ready anymore. And you can see that there are only 4 on 6 ready at the moment, but they are still all running. So that's some tricky part of the Kubernetes configuration. Because we didn't uncordon the node, we didn't drain it, it's a failure of the node, basically. Kubernetes is trying to save the configuration, and it is giving 5 minutes of grace period to the nodes before taking them down. And even then, they will just be stuck in a terminating state because it wasn't a clean node removal. So to make the demo more interesting, we're going to wait these 5 minutes for the nodes to be in a terminating state, so that when we kind of plug back the node, they will need to reconfigure together. So let's just wait these 5 minutes. Okay, so it's now in a terminating state. We are past the 5 minutes of grace period. So what we're going to do is that we are going to not physically plug back the node, but try to recover from this failure by moving the Linux container to another node. So let's have a look at the containers. You see, not very well, but you see that the number 4 is in error state. We're going to use liximove to move it to another one. So we're going to move the worker 4 to, let's say, number 1, for example. And because the data was being replicated by the Ceph storage backend, this is completely safe to do. Everything has been saved, replicated. And now we can just basically start it and wait for the node to join back the cluster. And you are going to see that the deployment is just going to go back online. So while this is happening, we can just have a look at what were the roles of the pods. Just as a quick checkup, and you can see that the number 0, which is in a terminating state, is not available. Like there is an error. For number 5, it's going to be the same. So number 1 is still master, number 2 master, 3 slave, number 4 has became master, and number 5 is in error because it was on the failed node. So let's see how is it starting. Okay, so number 4 is already running. It's now located on the Raspberry Pi number 1, as expected. What we can do is we can do a kube control get nodes to see if it's coming back in a ready state. Shouldn't be long, like the machine is basically starting, so microcade has to start to notify the cluster that it's back online. The cluster has to acknowledge that and to reconfigure to put everything back to normal. Okay, so now you can see that worker 4 is back online. It's ready. Although as we've waited for the 5 minutes of grace period, the pods are now in a terminating state. You see that we are now 0 on 1. What is going to happen is that the volume, the storage volume that was attached to the pod is going to be detached. A new pod is going to be instantiated, and the volume is going to be attached to the new pod. So what's going to happen is that we've been experiencing a node failure, and we had almost nothing to do apart from moving back the failed node to a working node. And everything is self-healing at the macrocade's level, that it's all coming back online and running. We just have to wait for the new pods to instantiate. And first for the old ones to disappear because we need to save this volume. Okay, so all the nodes, all the expired nodes are gone, and we have pods, sorry, all the expired pods are gone, and we now have our two new fresh nodes back in the cluster. What we can do is we can, for one last time, observe what's the roles of these pods. So you see that the number 0, which was a master before, is now a slave because of the failure, and that the roles have been redistributed. But basically, the cluster is back and is healthy. We can have a check to cluster information, that the cluster is in an okay state. You see that it has experienced some failures, obviously, but now all is all right. And we haven't lost any data, and we haven't had more to do than moving the failed container to a working node on the cluster. So that's this whole high available self-healing configuration that is really important to microclouds, that this microcloud stack is enabling through these technologies.
All right, Valentine, that was a fun ride, and it's almost over. We still have one more video, so stay tuned for the last one in this series when Valentine does a final teardown and summary of his innovation lab. We'll also share resources and point you to some of the fun ARM developer opportunities. As a reminder, don't forget to like this video, follow our channel, and we'll see you in the next ARM software developer breakdown.